I am going to solve this problem 2.6. So in this problem it is said they determine the magnitude of the resultant force and its direction measured clockwise from the positive u-axis, right? So in this diagram we have this u-axis and this v-axis, and we are required to find the resultant of these two forces with such orientation, and we are also asked to find the angle of the resultant with this u-axis, and that angle should be measured in the clockwise direction. So let's suppose if I apply the parallelogram law for vector addition, so I have to draw these forces parallel to one another. So I will move this force and I will place this force on the head of this F2, right? So this is that F1, and I will also have to draw this F2 on the head of F1. I have to move this and place its tail on the head of F1, right? So then this is F1. So this will be the resultant. By the head to tail rule, we have to draw this resultant, right? So this resultant should be directed from the tail of the first vector to the head of the last vector, right? So this is the resultant. Now we are asked to find this theta as well, right? So this is that theta. Let's suppose if I write that this is theta, right? And this theta should be measured in this direction, right? In the clockwise direction. So now as we can see that this angle is 75 degrees. The angle between these two axes is given, which is 75 degrees. So as we can see that this angle and this angle, they will be same as these angles are vertical angles, right? So this whole angle is 75, right? So if this is 75, so then let's suppose if this is some angle, right? So what will be this angle? So this angle, let's suppose that this angle is alpha. So alpha angle will be equal to, this will be 75 minus 30 degrees, right? So this will become 45 degrees. So this angle, the angle between F1 and the u-axis is 45 degrees. We have determined this, right? So this is 45 degrees. Now what is the angle between F1 and F2? So if I draw that angle, so this is that angle, right? This green one. So this is the angle between F1 and F2, and this will be the summation of this angle, this alpha plus this 30 degrees, right? So this green angle, let's suppose that this green angle is beta, right? So beta will be equal to alpha plus 30 degrees. So it is 45 plus 30 degrees, and again this comes out to be 75 degrees. So the angle between F1 and F2 is also 75 degrees, right? So now we know this angle. We know the magnitude of F1, this is 4 kilonewton, right? So this one is F2, right? So this is parallel to F2, so this is F2 and its magnitude is 6 kilonewton, and this one is F1, its magnitude is 4 kilonewton, right? Now let's suppose if I extend the line of action of this F2, right? So if this angle is beta, so then this is also that same angle beta, right? So this angle is also beta. So if this is beta, so then what will be this angle, right? So this angle and this beta angle, these two angles are supplementary angles, right? So their sum will be equal to 180 degrees, right? So let's suppose if this is gamma angle, right? So gamma, I can write that gamma plus beta will be equal to 180 degrees, and we need to determine this gamma, right? So 180 minus beta, right? So 180 minus 75 degrees, so this gives us 105 degrees, right? So 105. So gamma is 105 degrees, right? So this angle gamma is 105 degrees, and it is the angle between the F2 and F1, right? So this is F1 and this is F2. So now we can apply the cosine's law. We know this magnitude, this F2 magnitude is 6 kilonewton. We know this magnitude, which is 4 kilonewton, and we know the included angle between these two. So to find the magnitude of this resultant, we can apply cosine's law. So I can write that R square will be equal to F1 square plus f2 square minus 2 f1 f2, and this will be cos of gamma, right? So f1 is 4 kilonewton, so I will write 4 square plus 6 square minus 2 into 4 into 6, and this is cos of 105 degrees. And if we take the under the root as well, so this will give us the resultant magnitude. So this magnitude comes out to be 8.03 kilonewton, right? So this is the resultant magnitude. To find this theta, if we find this angle somehow, let's suppose if this angle is phi. So if we find this phi, so then this phi plus this theta is equal to 30 degrees. From here we can see, so this phi plus this small angle, right? So I can write that phi plus theta is equal to 30 degrees. So then if we determine this phi, so then theta will be equal to 30 minus phi, right? So we can find this phi using the sines law for this lower triangle, right? So if I apply sines law, so then we can write that sine of phi divided by the magnitude of the opposite side. So this is the opposite side, right? This f1. So I will write divided by 4, and I can write sine of gamma, right? This angle, and the magnitude of the opposite side. So I will divide it by r. So phi is equal to sine inverse 4 sine of gamma. So gamma is 105, right? So gamma is 105. We have determined this. So this is that gamma divided by r, the magnitude of the resultant. So it is 8.03. So if we solve this, so we will get this phi. So this phi comes out to be 28.76 degrees, right? So this is that phi angle. So now if we want to find this theta, so then theta will be equal to 30 minus 28.76. So this will give us the angle of the resultant with this u-axis, right? So this theta comes out to be 1.23 degrees, right? So this is the angle of the resultant with the u-axis, right? So this is that angle, this theta, right? So this is the solution of this problem. This is the resultant, and this is the angle theta with the u-axis.